And get this started. All right, good afternoon, folks. Just to reiterate Lorenzo's welcome. Thank you for taking the time today to join the webinar. We're going to be covering how to use Corelight data powered by Splunk to help with threat hunting exercises, right? And today we're going to get into and provide an overview of Corelight and how that data is generated, where the sensor is instrumented, and we'll get into how easily we can get that the extracted data into Splunk using the embedded Splunk forwarder on the appliance. Then we'll get into a hands-on lab, kind of exploring the Splunk, the Corelight application within Splunk, do some data exploration and security workflows. And then we'll get into two use cases around threat hunting. We'll look at some exfil, possible exfil within a network. And then we'll kind of dive deep into a trick bot use case as well to kind of do our threat hunting based off of SSL certificates and self-signed certificates. And then at the end there, we're going to kind of do and look at and see how we can start eliminating alert fatigue by automating some of these tasks using Splunk Phantom. All right, so let's see here. Threat hunters need access to a myriad of different data sources to include host and network level data. Splunk indexes all this data so they can provide fast results. The key as a responder is to get answers quickly to your hunting questions, answers to your hunting questions answered quickly. Now that you have a rich set of data, you can build playbooks to automate tasks using the Splunk Phantom. We'll get into how Corelight data can help with playbooks to help relieve the dreaded alert fatigue. This in turn will free up some more time for hunt exercises. And when instrumented correctly, the network provides a trusted source of highly relevant data. The host level data is good. However, once an actor gets control of the host, they have the ability to cover their tracks by manipulating the data. This is highly unlikely with the network. So we have a lot of protocols that can be decoded and hundreds of data elements. And Corelight provides value by extracting high fidelity layer 4 and layer 7 metadata that is then forwarded into Splunk for searching and indexing. The key for us is that both the request and response is in a single log entry. So you're not moving around different points in the data set. All of the data is available for you. And this is done and linked through fields for easy pivoting of multiple log entries. And we'll kind of get into the details of that later on in the presentation. So both SourceFire and Tenable started out with an open source solution that they commercialized. Zeek and Corelight is the same deal. Dr. Vern Paxson developed Zeek 25 years ago out of Lawrence Berkeley National Labs. It's a great open source solution that provides visibility into your network data. We have seen that over the years, the challenge with open source has been performance and manageability. Most implementations are only able to get at most 3 gigabits of performance utilizing the open source solution. Corelight can scale the performance up to 25 to 30 gigabits of sustained performance. So we overcame the performance problem and provide a centralized management suite. So Corelight has commercialized Zeek, but the key difference is that we still maintain and manage the open source project as well. So Corelight is very actively involved in the project, but our solution is starting to split and bifurcate, where we are adding intellectual property on the Corelight side, but still using Zeek as the core engine. So Corelight helps organizations to consolidate their passive network security stack. There are too many passive sensors working independently. Corelight provides an integrated sensor capable of providing IDS, NTA, PCAP, and NPM, or network performance monitoring, which is greater than the sum of its parts. Corelight provides a network traffic analysis engine using Zeek, which is the industry standard for IR and threat hunting. IR teams rely on Zeek to provide a deep and comprehensive visibility of network traffic. Couple this with the signature-based alerts from an IDS or the IDS module, alerts enriched with the powerful network metadata of Zeek. The enriched alerts can be quickly and accurately analyzed. So no more fumbling around the UI and trying to figure out where to find this data. It's all going to be stitched together. Since the sensor is extracting metadata from the network stream, you can get smart about your full packet capture strategy. With the integrated sensor, you can reduce your PCAP data by up to 90% by capturing packets that are relevant to your organization. This will provide a more efficient use of PCAP resources, allowing for longer retention times and/or a reduced footprint. And of course, all of this data is being forwarded into Splunk for analysis. This provides a single pane of glass for the analyst. No need to learn a point product that may not get used very often. They're familiar with the interface of Splunk, and thanks to their common information model, they can continue using common fields that they've already used to. Right. So this is a typical deployment from a sensor standpoint. As you can see, it is completely passive. The sensor is getting a copy of the traffic off of the network. It's going into your packet broker fabric. And then from there, it's getting forwarded into the Corelight sensor. And we've this here kind of indicates the various form factors that are available from Corelight. We've got Corelight cloud sensors that have the ability to run in AWS or Azure and monitor that traffic. We've got physical sensors that support anywhere from a couple of gigs all the way up to 25 to 30 gigs. And then there's also virtual sensor and a software sensor. Right? So as the data is coming in, the metadata is getting extracted out. And then we do have two other inputs into the platform. We've got the Intel feeds up top here, which you could either subscribe to third-party feeds or have your internal feeds that can get pushed into here. And as the data is being analyzed, we can enrich it and get any matches off of the Intel feeds. So in that case there, we're applying your Intel in a real time and raising notices based off of those hits. Right, and then down here from the input framework, right, so this is to help you enrich the metadata with your CMDB. So if you have particular servers or server farms that are of critical resources, we can tag those within the logs to allow the analyst to quickly determine and identify what the hosts are within that particular log. Right. And then, of course, as we mentioned before, all of that metadata that is getting extracted out is getting forwarded into Splunk. And the sensor is running a licensed Splunk forwarder within the platform, and we can either use a deployment server, a Splunk deployment server, to download the configuration into the Splunk forwarder. We can